Okay, Year 11 Advanced. We're going to look at question 4 from exercise 314. So, just straight from the textbook, we've had a request for a homework question, question 4. Okay, so here the questions are. Draw the graph of f of x equals x squared and f of x equals x minus 2 squared on the same number plane. Okay, so here we go. Mark your centimetre spacing. Okay, centimetre spacing there. Okay. Right, this is the y-axis, this is the x-axis. Alright. Now, this is just y equals x squared. So a couple of points will do. Do a little table of values if you wanted. X, y, minus 1, 0, 1. That'll be starters. You're going to get 1 there, 0 there, 1 there. So this is guide points there, there, there. So this is 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. And if you just draw your parabola like so. Okay, so there's y equals x squared. Done. Now, y equals x minus 2 squared is just y equals x squared shifted 2 units to the right. Okay, so that means the vertex is here. All points get shifted 2 units to the right, so this one goes 2 units. This point here will go 2 units. It'll do. This point here will go 2 units as well, so obviously that becomes an intersection point there. And it should go through now y equals x minus 2 squared. If I put x equals 0 for the y-intercept, right, then you're going to get 0 there and then 4. So it should go through, there's 2 there, there's 4. It'll go through 4 on the y-axis, that'll keep coming up here, through 4. There we go. Okay, so there's your 2 parabolas, that's done. Part B says from the graph find the number of points of intersection. Okay, well, there's only one point of intersection there. Okay, so I'm going to write that down. 1 point of intersection. Okay, now it says find the points of intersection from the graph or by using algebra. Well, from the graph, so graphically, you can see there the point there is 1, 1, right? 1, 1 is the intersection point. Okay, now what about algebraically? So you should be able to do it algebraically as well. Algebraically, what have we got? We've got, well, you've got to solve this simultaneously, don't you? Want to find out where they meet. So I'll put down x minus 2 squared is equal to x squared. It gives me x squared minus 4x plus 4 is equal to x squared. That cancels. So you're going to get minus 4x plus 4 is equal to 0. Then you're going to get 4 is equal to 4x. And that means x is equal to 1. So just one intersection point there. And then we'll sub that in to any of the other equations. So sub into, I'll choose the simplest one, y equals x squared, so therefore you get y equals 1 squared, which equals 1, so therefore 1, 1 is the intersection. Okay? Done. Okay, so that's question 4. There's also a request for question 5, so let's have a look at question 5. So we'll just rub this out. There's my duster, here we go. So question 5. Let's look at question 5. And I'll just look at question 5. Okay, so question 5 is very similar to question 4. And I'm not going to do question 6, that was requested. Question 6 is the same as 4 and 5. So once you've seen 4 and 5, have another go at 6. So here we've got f of x equals x squared and f of x equals x plus 2 squared. So the question is, find any points of intersection between these functions. Well, I'm just going to put each function, I'm going to equate them using simultaneous equations here. Okay, so just like in the other one, so you get x squared plus 4x plus 4 is equal to x squared. They cancel, so you're going to get 4x plus 4 is equal to 0. 4x equals negative 4, x equals negative 1. And sub x equals negative 1 into one of these equations. This is the easiest one. So put that into f of x equals x squared. Therefore, f of minus 1 is equal to minus 1 squared, which equals 1. So therefore, negative 1, that's 1 there, negative 1 and 1 is the intersection. Done. Okay, so that's question 4 and 5. You can have another go at question 6.